Okay, so you guys had your test yesterday, so make sure you turn that in before you go today. Today we're going to be looking at applications in construction. And actually the rest of the semester is going to be applications in construction for these trig formulas. For the next several days, we're going to be looking at areas and how these formulas can be used to find areas. Howdy. So let's say we have a triangle that looks something like this. This angle here is 42 degrees. This side down here is going to be 50 feet. And this side up here is going to be 45 feet. To find the area of a triangle, what is our standard formula for the area of a triangle? Yeah. Base times height divided by 2, or 1/2 base times height. Well, the base of this is the 50 feet. We don't know the height. But if I draw this in right here, that would be the height. The height could be found using a sine. The sine of that 42 degrees would equal that height over the 45 feet here. This is now the hypotenuse of that right triangle, right? So how would I solve for the height? Well, I would just multiply by 45. So 45 times the sine of 42 degrees. So in this formula up here, I can replace that height. So it'll be base times that 45. I'll put the base in there as 50. Times that 45 degree side times the sine of that angle of 42 degrees over 2. So 50 feet times 45 feet times sine of 42 degrees over 2. Which gives us an area of 752.77. And all those links are in feet, so that is in square feet. So what this does for us is it actually gives us a generic formula for area. If I have a triangle that looks like this, where I have, so I'm going to label A, B, C, so little a, little b, little c, where I am given sides A and sides B and angle C. So it's the same information we'd be given for a law of sines type problem. The area of that triangle, see it, Carter, is going to be side A times side B times the sine of angle C over 2. Make sense? Yes, no? So if I give you a triangle where I tell you this angle here is 44 degrees, this side down here is 32 inches, and this side up here is 29 inches. How are we going to find its area? Well, the area is going to be 32 times 29 times sine of 44 degrees divided by 2. So I'll punch it in the calculator. It's 32 times 29 times sine 44. Make sure you close that parentheses again. Divided by 2. 322.232. Bless you. Those links are in inches, so that's inches squared. So where'd those numbers come from? Right there. The big triangle is the generic formula. So this is your triangle, angles ABC, sides ABC. The area is length of side A times length of side B times the sine of angle C divided by 2. Okay. So if this angle here is 24 degrees, and this here is 53 feet, and this is 51 feet. In your notes, find the area of that triangle for me. Here, 549.70. And of course, the lengths are in feet, so that area is in square feet. Good. We'll give you a chance at redemption over there, Tate. Huh? We'll give you a chance at redemption over there. Hey. Find the area of that one in your notes. Did anybody notice what's different about this problem? Yeah, the angle is not between the two sides. I need two sides and the angle in between them. Notice up here, angles between the two sides. Angles between the two sides. C is between A and B. So before I can find an area here, I either have to find this side or have to find this angle. This angle would be quicker. So I use 38 over the sine of 79 degrees equals 41 over the sine of, I'm just going to call this A, B, and C, so that's sine of B that I'm actually finding up there. So I'm actually finding this angle first, but then I'll be able to get A. So I cross multiply and divide. Times sine of 79, close parentheses, divided by 38. Oh, I get an issue there, don't I? 1.06. That means this triangle cannot exist the way it does. Why not? Did you give them the same thing when you did it? Yeah, you can't do an inverse sine of a number larger than 1. It doesn't exist. So that triangle just cannot happen, can it? Never claimed to be nice. So on this one, I'm going to give you that this angle up here is 67 degrees. This side down here, 32 feet. And this side over here, 25 feet. Find its area. Well, you guys tell me what to do. I'll walk through this one with you. Yeah, we do not have the correct angle, so we're going to have to do some work here. 32 over the sine of 67 is 25 over sine of A. So our cross multiply and divide. Sine of 67 times 25 divided by 32. We get 0.7191. So A is going to be the inverse sine of that. 45.98. So this is 45.98 degrees. This is 67.02 degrees here. Now we're good to go. What do we do next? Perfect. 32 times 25 times the sine of 67.02 degrees over 2. $368.26. What's my units? Feet squared. There you go. Any questions? Not yet? Give me time, is that what you're saying? I have the sense that you guys are a little bit paranoid in this class.
What are you doing? What are you drawing? All these squares make sense.
Find the area of this parallelogram, and it is a parallelogram, I'll give you that. Anybody tell me how my formula is going to change? Yeah. If I divide it by 2, I'd be giving this just this half. The other half is going to be exactly the same, so I just don't divide by 2. So it'll be 28 times 62 times the sine, 74 degrees. $1668.75. Those are in feet, so this is in square feet. Again, parallelogram. I give you this side here is 28 inches, and this side up here is going to be 12 inches, and this angle here is 67 degrees. What do I need to do? I need to find, this angle here I can find really easy. Why is that so easy? There you go. These two lines are parallel because it's a parallelogram, right? So these two angles are either equal or supplement. Well, they're definitely not equal, so they're supplements. This is 113 degrees. So my area is 28 times 12 times the sine of 113 degrees. $309.29. And of course those things are in inches, so this is in square inches. How would it have changed your answer if you'd screwed up and used the 67? Why does it come out to the same number?
Because the 12 is also on the bottom.
Well, the 12 would also be on the bottom. Well, and also these are supplements, right? Supplements have the same sign. Well, let's explore something maybe a touch more complex. If I give it that 63 degrees, this is 50 feet, and this over here is 30 feet. I'm just going to double check something here quick. Oh, you bastard. Oh, I see. Oh, well. We're just going to wing it. If I tell you that this side up here is 27 feet, and this side over here let's say this one is 48 feet. Find the area. Having some issues, isn't it? I'll give you a hint and cut it across here. So then you find the area of this triangle. Yeah, that area. 30 times 50 times the sine of 63 degrees. What do I have to remember to do? Divide by 2. So 668.25. That's feet squared. So that's that piece. But this piece over here, we got another issue. Well, I can find that side, can I? How do I find that side? Yep, it is 30 squared plus 50 squared minus 2 times 30 times 50 times the cosine of 63 degrees. And then I got to square root it. Second, square root 30 squared plus 50 squared minus 2 times 30 times 50 times cosine 63. 45.14 feet. Once I have that, guess what? I know my perimeter is 120.14 feet. How did I get that? Added them up. I know my semi-perimeter is 60.07 feet. So therefore, the area of that piece must be the square root of 60.07 times 60.07 minus 45.14 times 60.07 minus 27 times 60.07 minus 48. Does that formula look familiar? Good old Mr. Huron. 598.31. So we simply have to add those two measurements, two areas. To give us 1266.56. Pretty simple, right? How you guys doing? Do another one? How about I let you do another one in homework and we'll talk about it on Tuesday.
Hey, remember, you asked for it.
I want to move up to something a little bit more complex. A little bit more sides. We're going to look at regular polygons. What do I mean by regular polygons? All the sides are the same, all the angles are the same, yes. So, in a regular polygon, how do we find, first of all, the angle sum? (180 times n minus 2, right? So for this one, that'd be 180 times 6 minus 2, which would be 720 degrees. If it is a regular polygon, how do you find the interior angle? Well, remember, interior angle is this angle right here, right? The angle sum is 180 times n minus 2. So all those angles make 180 times n minus 2. Well, how many angles are there? N of them, right? So we divide by n, correct? So for this particular one, we take our 720, we divide by 6, that'd be 120 degrees per angle. But this formula here is still quite important. I'm going to do this. I'm going to take it over here. 180 times n minus 2 over n. I'm going to distribute the 180. 180 times n, 180 n. 180 times negative 2, negative 360. Over n. If I divide 180n divided by n, I get 180. 360 divided by n, or negative 360 divided by n is negative 360 over n. That is another way of writing the formula for the interior angle. Is 180 minus 360 over n. So let's continue. I'm going to find this by cutting it into triangles. Since this is a regular polygon, I can go from the center of the polygon and cut it into triangles. And all those triangles are the same size, right? Okay. What is this central angle here? How do I find it?
Because normally it's 120, but
that central angle is just 360 degrees divided by n sides. What you were saying really doesn't apply, because if it doesn't have 6 sides, it won't work. But 8 sides, that wouldn't work. So it is just 360 divided by n. So for this case, 360 divided by 6, 360 degrees. If I find that length or that height of that triangle, how do I find the height of that triangle? Well, what I'm going to do is I'm going to use this here. I'm going to cut the triangle in half so I have a right triangle. So let's pull that down here to look at. In this right triangle, I now know that this angle here is half of this one, right? Right? So that's going to be 360 over n divided by 2. It becomes 180 over n. Because the whole angle here was 360 divided by n. This angle is just 180 divided by n. Now we're getting somewhere. Oops. If I am told that the length of the side of my figure here is S, what's the length of this side here? S over 2, right? Half of the side, right? Because remember, really, that's just half of that whole triangle. So this height here can be found using a tangent. Tangent of that angle of 180 over n equals S over 2 over that height. So that height is going to equal 1 times S over 2, which is just S over 2, divided by the tangent of 180 over n. So that's our height. So what's the area of one of these? And I'm going to rewrite this just a little bit, by the way. I'm going to write it like this. It's just going to be S over, dividing by 2, I'm going to put the 2 on bottom. 2 times the tangent of 180 over n. That's my height. So the area of that triangle is the length of the side, S, right? This whole thing here. Now I'm finding actually the length of this whole triangle here, like this. Where this is now S and this is the height. So it's the length of this whole side, S, times that height of S over 2 times the tangent of 180 over n, times 1/2, right? 1/2 base times height. But what do I get here? S times S is S squared. On bottom, I have 2 times the tangent of 180 over n times 2, so that's 4 times the tangent of 180 over n, or 180 over n, right? So what that gives me right there is one of these little triangles. How many of those triangles do I have? Well, in this case, 6, but normally it would be just n of them, however many sides there are. There's one triangle formed on each side, right? So just times n. So the area of that regular polygon is n, the number of sides, times s squared. Some formulas they put in L squared for the length of the side instead of S for the side squared, over 4 times the tangent of 180 over n. So now let's put this to use. How would we make this work? Let's work with our regular hexagon here. The regular hexagon with a side of 12 feet. Its area. What's n? 6 times 12 squared over 4 times the tangent of 180 over 6. Very good. Now, how do we punch this in the calculator? This is very important. We can do 6 times our 12 squared. And then we can hit divided by. But now we got to use a parenthesis here. Parenthesis 4 times the tangent. Now notice when I hit tangent, it brings up a parenthesis. 180 divided by 6. Now I've got to close the parenthesis for the tangent. Then I also have to close this other parenthesis. So I've got to close the parenthesis twice. Get 374.12. You could, yes. Yeah. Richard, your calculator works differently, of course. Can you figure out how to use it on yours?
I can figure it out.
You got her? Okay. The rest of you, did you get it to work?
Mm-hmm.
Cool. This is a regular what? Octagon. Yes, let's claim it looks like a regular octagon at least. And let's say it is 8 feet on a side. How would I find its area? Perfect. 8 is the number of sides times 8 is the length of the side, so that'll be squared, over 4 times tangent of 180 over 8. Let me know what you get. 309.02? Perfect. Tate? Okay. Getting her? Good deal. Okay, Tate.
Okay, Tate.
Here's one for you.
Ew.
We want to build a gazebo. I'll let you pick. 6, 8, or 10 sides? 8 sides. Yep, 8 is pretty common for gazebo. I have seen 10-sided. Well, it's just they get closer to the round effect is what they do. I have seen some 12-sided ones too, but they're some huge ones. Dodecagon. Now, here's the deal. This is a regular octagon we're going to make. But building code says anything greater than 250 square feet needs a permit or counts as an outbuilding. And this person already has a garage, and their area only allows one outbuilding. So in other words, this has to be less than or equal to, well, less than basically 250 square feet. So what we're going to do is this. Our area is 250 square feet. That's going to equal 8, which is our number of sides, times S, which is our length of the side squared, over 4 times the tangent of 180 over 8. So the first thing we're going to do is we're going to multiply by this thing here, right? So 250 times that, 250 times 4 times the tangent of 180 over 8. Close that up. So that's at 414.21. What would be my next step now solving for S? Divide by 8. So 51.78. Now what's my last step? Square root. Cancels out the squared on the S. So second square root, second answer. 7.20 feet. Probably 7.20 would actually be rounding up. So I probably should round to 7.19 feet. Because if I round it up, that might put me slightly over the 250 square feet, right? So even though that number should round up, we better round it down. So 7.19, which is, of course, 0.19 times 12 is 2.28 inches. Subtract the 2.28 times 16 is 4/16. So that is 7 feet, 2 and 4/16 or 2 1/4 inches. That's how long each side can be. Now, if it were me, I'd probably just build my side 7 feet and tell them, close enough? Yeah. You don't want some building inspector who doesn't know what he's doing coming out, measuring it up, and trying to calculate the area on his own. And if you're down to like 2 square inches away, you don't want him screwing up the calculation and saying, nope, tear it down. So for you guys to play with,
That's going to be that's a joke. No, it's 15 cents. Okay.
12 sides. I didn't draw it very well. Did you expect any less from me? Well played. It's 12-sided, is all, right? Area has to stay at or below 400 square feet. Figure out in your notes what the length of the side would be. How do we set it up? 400 equals 12 times S squared So then the first thing we do is multiply by that, right? So 400 times 4 times tangent 180 over 12. Something did not register. Let's try that again. That looks better. So 428.72. What's next? Divide by 12. 35.73. And then square root. Come on. 9.8. 9.7 we'll probably have to go with. Yep, not quite 6. Be like 11 and 5/8 inches. So 5 foot 11 and 5/8. I'd probably go 5'11" just to have some leeway. 5'10".
1 foot size.
Okay. How'd you guys feel about this stuff?
Too bad it's practice.
It's not horrible.
Got a couple of worksheets I'm going to pass out for you. Don't forget, you guys got a test that you owe me here before you leave.
Took it out.
Whatever happened to doing tests by yourself?